Hello and welcome back to what will be the final installment on graphing trig functions. We're basically doing one example that comes from a real-life situation, and it reads, a Ferris wheel with a diameter of 80 meters takes 50 seconds to do a rotation. The maximum height is 82 meters. Determine an equation that would describe the motion of this Ferris wheel. All right, well, here's the scoop. I like to do these questions by drawing them out. So I set up a little bit of a grid, and then I try to figure out some key points on that grid. And that's usually enough to get me going on this. So, first things first, the maximum height was 82. Okay. Now, if the diameter of the wheel is 80 meters, that means that the minimum height, if you were on the Ferris wheel, would be down here, and that would be 2 meters, right? So it means when you get on the Ferris wheel, you must be 2 meters above the ground, and then it whisks you up to its maximum height of 82 meters, given its diameter of 80 meters. So let's just assume that you get on when right at time 0. You start the clock when you're at the bottom. So then it takes you up to its maximum, somewhere up here. Then you look around and everything looks great, and then you come back down. Okay, back down to your minimum of 2. Now, how long is that all going to take? Says here 50 seconds to do a complete rotation, so to bring you back down to the ground. So I think I've got everything I need drawn out here, so I'm going to start filling in some of the information. Remember, your basic trig equation you have to start with an amplitude. Doesn't matter whether you go with, actually let's go height equals. Doesn't matter whether it's sine or cos, we'll determine that afterwards. Whoops. Sine or cos, and then the next thing that's important is b, which affects the period, and then we have x, which would be our, actually why don't we use time for that, put t in there for time, and then we would have some sort of a phase shift, and then lastly we would have probably a vertical shift. So these are the a, b, c, and d are the things we have to determine for this equation. The easiest two is the vertical shift and the amplitude. So let's start and try and figure out where is the middle line at. Okay, so to figure this guy out, if you think your maximum is 82 and your minimum is 2, and you got to be an equal distance above and below, the easiest thing to do is just figure out, well, what's my total distance from my maximum to my minimum? Well, that would be 80. And if I just split that in half, that means the amplitude here must be 40. So it's pretty easy to get A. So I go, yep, that's 40. Then I'll have sine or cos. Then I got to figure out the number that affects the period, but we'll do that in a moment. And phase shift, well, that's going to change, depends on which of these functions you're going to work with. But let's get D here. D is pretty easy. If your minimum's 2 and you know your amplitude is 40, then it's 2 plus 40, so we must be at 42. So this must be plus 42. Okay, next thing I'm going to figure out is what is B, and then we'll try and work out what these phase shifts are. So the number B, well, the period is 50, and how do we get the period? Well, it's the reciprocal of B, that is multiplying the original period, which is 2 pi. Now, I want to solve this for B. So I'm going to multiply both sides by B. So that gives me 50b equals, and then the b's would have canceled, so I have 2 pi. And then I'll just divide by 50. So B must be 2 pi divided by 50. And I could reduce that a little bit, put it into lower terms, so it's pi over 25. Okay, we've got everything except the phase shift. So I'm going to give myself a little bit of room up here because I kind of like to hang on to that drawing there. So let's get rid of all this stuff. I think most people have that in their notes. Let's get rid of that. And we're going to put our finished products up here. So the height on the Ferris wheel is given by 40 times. So let's do one of these with sine. The number that's in front is pi over 25. And then we've got to figure out that phase shift. Yep. And then we have a vertical shift of 42. Okay. Well, where would sine want to start? Sine would want to start right here. Now, the question is, where is that? Where are we here? Well, the trick is these graphs tend to work in 4 important sections. So here's where it starts, and it ends at 50. So halfway through, okay, this location would be 25, and then we just split this in half again. So this has to be half of 0 to 25, so it's 12.5. That's our phase shift for sine. Okay, so we go, okay, there's one of our possible equations. Another equation would be if we go with cosine. Notice nothing's really changing except oh, I was going to use t for this. Oh, well, it's too late now. See, over here I use t for time. Kind of makes sense because along the x-axis, these x numbers are all time in seconds. But you know what? Doesn't really matter. Here we've shifted. We want to start cosine right here. Well, that's 25 to the right. So there we go. And here's another very popular equation that works, and that is you just make it negative because then you don't have to worry about any phase shift at all. See, because then you can just start right here, don't phase shift it to the left or right at all, and there you have it. Some pretty snazzy equations to describe your height on a Ferris wheel as time marches on. And speaking of time, I'm going to stop because this has gone on long enough.